All right, good day, everyone. What we're going to be talking about today is just continuing on with polynomials. Yesterday we talked about basically using a calculator to help figure out how to find them and things like that, using that regression model with a set of data. Today we're actually going to look at specific polynomials, and we're going to try to find important features of each one, okay? Things that can help us in the long run, things that can kind of guide us along the way. But we want to be able to be aware of, like, what do we want to look for when we see an equation? What do we want to look for when we see a graph and things like that, okay? So we got basically a couple quick problems to go through, talk about a lot of different things. What I would suggest doing is maybe as we go along with this video, if you could, take some notes on this just because there's so many things that we really need from a polynomial to really analyze it, to get all of our data. And as you do this for a while, you'll start being more and more confident with, like, okay, what am I looking for? But early on, it is a lot of information to start with, okay? So let's just look at one of these real quick. Letter A here. We want to look for key features of this graph. Okay, we want to actually understand, like, what are some key things that we need to find about this graph. So we're going to go through a couple of important concepts just to begin with. The first one being, one of the things we always want to do is just analyze domain and range. Okay, let's understand, like, what is the domain and range of this graph. Okay, so let's go ahead and get those first. So we have domain. And range. Well, domain and range are restrictions that are set on our x and y values, okay? And one of the ways you can look at this is in a graph like this where I have lines on the left and to the right, on top of the fact where both lines are going up and down, okay? I can look at this graph itself and say there's no restrictions on any of this, okay? I could also do this and say, like, an x cubed plus 3x squared minus 5x minus 7. There's really nothing in them that's going to restrict my equation, right? So when I look at this problem, my domain is all real numbers, and so is my range, okay? With polynomials, when this changes, like, when will you not get all real numbers for polynomials? When you have to actually think of, like, a quadratic when it goes like this, where my range is going to be set to wherever the lowest point or wherever my vertex is at, or maybe that's my maximum or my minimum value, okay? So currently with the cubic problem, I shouldn't have any restrictions for that, okay? The next one we want to talk about, the next kind of key one, something you might want to bring back is end behavior, okay? Now what end behavior does is it describes how this graph is going to end and how it's going to start. Okay, it really describes where my lines are pointing at each end of this graph. Okay, so end behavior is really just two specific aspects. We want to describe it as x when it's going to negative infinity, which just means left, and x going to positive infinity. So we have left and right. So when I look to the left side of this graph, we notice that the line's going down. So to describe that, I want to say y is going to negative infinity, okay, because it's going down, okay? Then for the right-hand side, I'm going to say, okay, if I look to the right, this line is going up. So that means y is going to positive infinity, okay? And so that's kind of bringing back end behavior from last year, and really all end behavior does is it describes on each end of this graph, where is that line ending up, okay? To make room for ourselves, we'll just cross this one out. Now, after this, what we want to do is find a lot of important things about this graph. So we want to know, like, what else is happening. And we want to know things like the x-intercepts, the y-intercepts. So we want x-intercepts, y-intercepts, okay? We want to know max. We want to know mins. Okay, and for all of these, what we really want to do is just grab these from the calculator, okay? Because a lot of this piece of information, unless this is a perfectly factorable value, which we'll talk about later on, we want to actually gather these values. But unfortunately, in this case, just because I know the answers to things like that, this will not be nice answers. Okay, so let's go ahead and just talk about a few of these. For the x-intercepts, I will end up using the calculator. But for the first one we want to do, let's just talk about the y-intercept. The y-intercept should be easy because if you remember back to just basically any point in time when we actually solve for it, really all we have to do is we have to plug in a 0 for all of our x's. Well, to find our y-intercept, if I were to plug in a 0 for all of these x's, notice how they would all cancel out and I'd be left with -7. On top of that, you can pretty much just look at this graph here and see that, right? If I look at this graph in particular, my y-intercept is sitting right there, okay? So what I want to do is gather that. My y-intercept is -7. Let's talk about our x-intercepts, okay? Now, for the x-intercepts, you are going to want to use the calculator, so we're going to go through a couple ways to actually solve it. I'll go ahead and show you one of these methods, just so you have it, and then I'll just kind of write them out just to speed up the video for you. So if I want to find any of my x-intercepts, I'm going to go to Second Calc. I'm going to go down to 0 because an x-intercept is when I get an answer of 0, okay? I'm going to hit enter. And then they're always going to tell me this left bound and right bound thing. So what I want to do is just basically take my little coordinate here. If that's my x-intercept right here, I want to be on the left-hand side of it. Then I want to be on the right-hand side of it. So notice how the two lines are encompassing that intercept. And then the guess portion, you can get close to it, but honestly, as long as you're inside the lines, I think it will work. And I get to my first x-intercept, which is -3.82. Okay? So I go to here. -3.82 is one of my values. Now, if I did that for the other two, okay, my values would come out to be -1 and 1.828. Okay? So I can find those three values using the calculator just by finding those specific points. Okay? The next thing I want to find is my max and min. And my maximum minimum should be described as the highest and lowest point of this graph. So I should have a maximum at this coordinate up here, as well as a minimum at this coordinate down here. Okay? So same thing, we're going to go to our calculator. My maximum point's up here. So if I go to second trace again, notice I have a minimum and a maximum. They're both going to be done the same way, just depending on what you're looking for. If I want to find my maximum, I'm going to go down to it. And it's going to be the same process. I want to be on the left-hand side, so I put one there. The right-hand side, so I put one there. And then right where the guess point's at. And I get a maximum value of about -2.63 and then 8.7. So my maximum coordinate is -2.7, and the other value was 8.7. And then same thing, I can repeat this process with the minimum. If I were to do that, the minimum would come out to be 0.633 and -8.7. Okay? So once again, I know this is a lot of information kind of thrown at you, but these are all things that I can just gather from the graph just by looking at it. Okay? Other things I can use the calculator to help me get. Now, later on, we won't even need the calculator because we'll have factorable equations, but right now, just because we are getting answers like this, we can go ahead and use the calculator and actually come up with the answers for them, okay? But the first key thing to understand is, like, what are we trying to find in the graph? Well, these are all important key features. The domain and range, the end behavior, okay? Because end behavior is going to help me describe, like, what type of degree I'm going to have later on. X-intercepts, obviously, those are always important. They basically give me a coordinate. Y-intercept, same thing, they give me a coordinate and so forth, okay? So all these are important pieces, important features of the graph that we're going to need. Being able to find those now is going to be essential, okay? So let's continue on and talk about other different things we could solve in a graph, other different things we could find, okay? Well, there's certain things I can use in a graph that are really going to help me describe the graph itself, okay? So just to make room, let's just talk about A, okay? Because a lot of these, it gets really repetitive after we go through a bunch of these. And obviously, we'll talk about these in class as well. But let's just talk about letter A, okay? First and foremost, let's talk about the degree of the polynomial, okay? The degree is always described by the highest exponent. So highest exponent, okay? That's always going to be the first thing that's going to describe it to you. So in this problem, letter A, we have a -1/2 x squared minus 4x. In this case, we have an x squared, so I have a degree 2. The reason that's important is because it's telling us how many possible zeros we could have, okay? I could have a possible 2 zeros, okay? That is a key statement, okay? Possible 2 zeros, because when I'm actually solving these problems out, I want to know how many total times I can cross the x-axis. I shouldn't have 3 x values or 3 x coordinates on an x squared function, okay? So that's kind of an important first step, okay? Next, we have our leading coefficient, okay? And the key thing to understand about this one is a leading coefficient is going to describe which direction this graph's going to go. So I'll just write this. It describes direction, okay? In this case, my leading coefficient, my LC, is going to equal -1/2. And the reason this is important is because it's telling us that this is going to point down, okay? Just to quickly kind of describe what that means, if you think about like an x squared graph, if we have a regular x squared graph, it's going to look like this, okay? Notice how it's a value of 1 in front. I have a leading coefficient of 1. If I have a -1 in front, my graph all of a sudden does this. Okay, so notice how that leading coefficient drastically changes just based off the way your graph points, okay? Now, that's huge because by understanding that, I can pretty much describe end behavior to you. I know because of that leading coefficient, my graph's going to look like this. So now I can also do end behavior, right? Because I know what the graph's going to look like based off the leading coefficient. Well, because they're both pointing down, as x approaches to the left, y is going to go down. As x approaches to the right, y is also going to go down, okay? So that's kind of the key thing you want to understand is that because the leading coefficient and because I know the degree, I know it's an x squared, I know it's going to be pointing down, and so now I have that value given to me. I know what my end behavior is going to be. The next one, the maximum number of zeros. Well, that's based off the degree. We've already talked about that, okay? The maximum number of zeros in this problem is going to be 2 because I have a degree 2 polynomial. The last one we want to talk about is turning points, okay? What are the maximum number of turning points? And understand a turning point is literally what it's described as. Where's the graph turning and going another direction? Basically an increase to a decrease or a decrease to an increase, okay? Well, if you notice, if I just look at this graph over here, I have 2 total turning points. One here, okay? Notice the turning points really are just a maximum or a minimum. That makes sense, right? If I have a maximum, that means it had to go from an increase down to a decrease because it's the highest point, okay? Notice how this had to go from an increase to a decrease to become a maximum. Well, same thing with a minimum. It has to create a turning point because it goes from a decrease to an increase, okay? So really all a turning point is a maximum or a minimum value within this graph. Well, how can we tell how many total possible we could have in a graph? Well, the easy part to do this is you just take the degree and you subtract 1 from it. Notice how in this problem here we had an x cubed. Well, if I took 3 and subtracted 1 to it, I could have a possible 2 turning points, okay? And that's really all you have to do. So for like this problem, I have a degree 2 polynomial, which means if I'm thinking about my turning points, I could have 1 possible, or I should say in this case, I think you're going to need 1. I think 1's the lowest value you could even have. But in this case, I should have 1 possible turning point, okay? Because I took the degree, which was 2, and subtracted 1 from it. So, excuse me. Notice how all these different values I can actually solve out and actually gather answers based off of them. Okay, the degree tells me all the possible zeros. The leading coefficient, okay, this one tells me the actual direction of my graph. The end behavior describes the lines of the graph, okay? The turning point tells me how many maximum minimums I'm going to have. So all these points are important features to understand and be able to actually take out of a graph early on, okay? We're going to need all of these when we actually start factoring and getting the zeros and actually graphing these by hand. we have to know, like, okay, if I have a degree of 3, how many zeros am I looking for? If I have a leading coefficient that's negative, what's that going to do to my graph? If I have 3 possible turning points, what should I be expecting my maximum minimum? Okay. So notice how all these things can describe a little bit of the graph for us. Okay. But however, we will be going through this in class. That was all we wanted to go through today. We'll be talking about a couple more of these, describing a couple things. Besides that, finish up the video and have a great day.